Hello friends, welcome back to our channel. So in the previous session we have seen how to create the linked list, single linked list, and how to insert the element into the single linked list. That means at the beginning, at the end, and at the specific position. And in today's session we'll discuss about the delete operation. So how can we delete the element from the beginning, end, and the specific position for the single linked list. So in the previous session we have seen how to create the single linked list. So directly I will draw the diagram. So let us take a few nodes and then we'll write the code. Okay. So after this session, that means after this theoretical session, I will show you the demonstration of all these three concepts. That means deleting at the end, beginning, and position, right? So let us take five nodes, right? So this is the linked list with the 5 nodes. So let it be 10, 20, 30, 40, and 50. And the address is some 1000, 1100, 1200, 1300, 1400, right? And this 1100 should be here, and this 1200 should be here, because this is the link of next node, right? So this 1300 should be here, and this 1400 should be here, and finally the last element will be none. So for this purpose we have created two different classes. One is a node and another one is for linked list, right? So after creating this one, now how to delete this one, how to delete the element. So this is the head, okay, self.head. This is pointing towards the first element. Now deletion at beginning, right? So in this beginning, deletion in the beginning, that means we have to delete this node. So in order to delete this node, if you disconnect the link between these two nodes, automatically the element will be removed, right? So here we are not having any free function, which we have discussed in the C programming, right? So in C programming we are supposed to use a dynamic memory allocation for this linked list, and we have to free the element, right? So here we are not having any free functions. So directly we can remove the link between the first node and the last node, and we need to change the head to second node. We need to change the head to second node. For this purpose, what we have to do, and see, go here, temp is equal to self.head. Temp is equal to self.head. So automatically the temp will be here, right? Now self.head is equal to temp.next. So temp.next means 1100, okay? Temp.next means 1100, and at that particular 1100 is assigned to self.head. So automatically now this self.head will be assigned to here, self.head. Now what we have to do, we have to make this as none. So we need to disconnect the link. So just we are moving the head to second position, because after deleting the first element, the second element will be the head, right? So temp.next is equal to none. So obviously this 1100 will be removed here, and it will be assigned to none, so that automatically the link will be disconnected. So now the self.head is pointing towards 20, and the elements after deleting the first element is 20, 30, 40, 50. This is a simple procedure. So if you draw the diagram, then it would be very easy to write these steps. Okay, just we are moving the head value to the second value, because after deleting the first value, the second value will be the head. So we are just removing the head, and just that is assigned to some temporary variable, because we need to disconnect the link. So temp.next is equal to none. That's it. Right? So hope you understood this one. So deletion at beginning. It's a very simple. Right? Now we will see deletion at end. Deletion at end. So let us change it. So this will be the self.head, and this is the link, and instead of none there must be the link 1100. Right? Now we need to delete the last element, that means this element. Right? So in order to delete this element, we need to travel from first element to this element. Okay, this element, and we need to change this element as none. We need to change this element as none. So just initialize some temporary variable to head, so that we can travel by using the temporary variable. So automatically temp will be at the top position. Now while just a second, yeah, no, while temp.next is not none. So unless it becomes not none, we need to move the temp value to the last. So temp is equal to temp.next. So obviously now for first iteration it will check for temp.next. So 1100, it is not none. So automatically temp is equal to temp.next. Now the temporary variable will move towards here. Okay. Now again, this is the temp. In the second iteration, again temp.next is not none, right? So again change the temp value. Temp is equal to temp.next. Now temp value will be 1200. So obviously it will point in towards here, right? It will point towards here. Now again temp.next is 1300. It's not none. So again change temp to temp.next. Again temp will be moved towards here. Again not none. It will be moved towards here. Right? Now we need to change the link. That means disconnect the link. We need to change this value. So how to get this temporary back? So that's not possible. So that's why we can create one more variable called previous is equal to self.head. Okay. So automatically this is the previous. This will again refer to previous. And instead of taking temp value, okay, as a self.head, I will go with the self.head.next. Self.head.next. Automatically the temp value will be, temp value will be self.head.next. It means 1100. So this will be the temp value. So I am initializing self.head as a previous, self.head.next as the second element. That means that second elements are temp. So automatically whenever the temp.next is not none, just move the temp value as well as the previous value. So previous also just move previous.next. So automatically for the first iteration temp will be moving towards here and previous will be moving towards here. Right? So in the second iteration temp will be moving towards here and previous will be moving towards here. And in the third iteration the temp will be moving towards here and the previous will be moving towards here. So automatically the loop will be terminated, because here the temp.next will be none. So automatically it will be terminated. Now you can simply use this one to make this link as a none. That means in order to disconnect the link. So what is this value? That is nothing but, so come out from the loop. So previous.next. So previous is pointing towards 1300. So previous.next means 1400. Make that value as a none. So automatically this 1400 will be replaced with none, so that the link will be disconnected here. So automatically the 50 will be deleted. The 50 will be deleted. So we are, in our linked list we are having only 4 elements, 10, 20, 30, 40. Right? So hope you understood. In order to get the previous element, in order to disconnect the last but one element, we are just initializing one more variable called previous, and we are just traveling from both the temp and previous for each and every iteration. Right? The head value is assigned to previous and head dot next. That means the next value is assigned to the temporary variable. So whenever the temp reaches to last element, previous will be reaching towards the last but one element. So like that we can change the, we can delete the last element. Okay. So hope you understood this one. Right. Next we'll move on with the third one, that is deleting the element at particular position. Right. That's also very simple. The same concept will be done. The same concept. See, I will tell you. Specified position, let it be position. Right. Now again the same thing, we need to travel from first element to that particular position, and position but one element should be the link of position previous element should be kept as none, so that the two elements will be disconnected. For example, if you want to delete the third element, the temporary variable will be moving towards this one, and we need to make this element as the value of this one. That means the address of this one should be placed at this place. Okay. So for this purpose also we are just taking temporary as the self dot next. So this will be the temp, and previous is equal to self dot head. So this will be the previous. Okay. And next, instead of using the while, I will just move the for loop, because we know the position for I in range of 1 to position minus 1, from 1 to position minus 1. So if position is 3, so the range will be from 1 to position minus 1, 2. 1 to 2. Right? That means, see, for the first iteration, the temp will be self dot next. So when I is equal to 1, so temp is equal to temp dot next. Temp is equal to temp dot next means 1200. So temp now pointing towards 1200. Right? Again, previous is equal to previous dot next. So previous is equal to previous dot next means previous will be assigned to 1100. So here it will be pointing previous. Right? Now again I value becomes 2. Automatically we need to stop here. So just stop here. Now what we have to do? So just we need to remove this element, this node. Okay, we need to remove this node. For removing this node, just disconnect the link between these two. So automatically previous dot next is equal to, and link the next one. So how to get this one? Temp dot next. So 1300 is the address of this node, right? That 1300 should be placed at this position. Instead of 1200, we need to place this one. So I will go with the temp dot next. The code is same, right? So automatically when you assign this one, instead of 1200, we'll get the 1300. Okay, automatically this link will be disconnected. Right? And this link will be established to here, and we need to remove this one. So obviously temp dot next is equal to none. So automatically this link is also removed. So it will be none. So the link will also be removed. Right? So simple steps. So if it is 3, if it is fourth element, in order to remove the fourth element, the temp should be traveled towards the 40 and the previous should be traveled towards 30. So automatically the previous next is equal to temp dot next, and disconnect the link. Disconnect the link. Right? So hope you understood this deletion process. So we have seen the three things. So how we can delete the element from the starting position, and how we can delete the element from the ending position, and how we can delete the element from the specified position. So we need to give the position, and from that position the element should be deleted. So very simple thing, and for all the data structure problems, just draw the diagram so that definitely you can easily grasp the concept. You can easily write the code, right? Yeah. Now let us move on to the interpreter, and I will execute all these three cases. That means how can we delete from the starting, ending and specified position, right? So let's move on to the system. Hello friends. So just now we have seen how can we delete the element in the linked list. That means deletion can be done at the beginning, deletion can be done at the end, or we can specify the position so that the deletion can be done at that particular position. Now let's write a program to demonstrate all these three cases. That means deletion at end, start and specified position. So for that, just we'll create a linked list with a few elements, and then we'll perform this delete operation. So already in the previous session we have seen how to create the single linked list. So I will once again I will repeat that one. So first of all, we need to create a class node with the two variables, that is data and next. So I will define the constructor init, okay, and inside that I will go with the self comma data, and which the data will be assigned to self dot data is equal to data, and self dot next is equal to none. So initially there will be no value assigned. Then we'll go with a again we'll go with another class in order to create the linked list. So I will go with the class SLL, right? So here again I will go with a constructor, so init, and I will go with the self, and here I will initialize the head with a none. So initially there will be no element, so none will be there. And now I define display function. So in order to display the elements, go with the display function. And now if self dot head is none, automatically we can say that so empty single linked list, otherwise else. So if else, just loop the thing while temp, okay, print temp dot data, right, and use the arrow marks for representation, and end is equal to, so everything will be displayed in the single line. So next you change the temp value, temp is equal to temp is equal to temp dot next, right? So now we'll create a node. So I will go with a linked list. L is equal to SLL. So L is an object, and now I will create a node. N1 is equal to node of 10, and see n self dot head is equal to n1, right? N1 will be the head. Now create n2 is equal to node of 20, and then n1 dot next is equal to n2. Similarly, n3 is equal to node of 30, and n2 dot next is equal to n3, because the previous node, the next node link will be given to the present node next, right? So let us stop here, and I will go with the display function. So whether it is displaying correct or not, we'll execute this one. So we got some error. L dot head, local variable temp reference before assignment. So yeah, temp is equal to self dot head. We can observe 10, 20, 30, and also we can go with the two more elements. So then next we will go with the deletion operation, and 4 is equal to node of 40, and n3 dot next is equal to n4. Similarly, n5 is equal to node of 50, n4 dot next is equal to n5. So if you execute that, so so I have created the linked list. I have created the linked list and I am displaying the values. So for that we are getting some 5 values. Now we'll write the code for deleting the element from the beginning. So define delete underscore beginning of cell. So here we are not passing any argument here, just we are deleting the element. So if you delete the element, automatically the temp value, just assign the temp to self.head, so that next, now the new element, so the first element has been deleted, right? So this is the first element, this first element had been deleted, and now the head element will be this one. The head element will be this one. So what is the reference of this one? This is nothing but temp.next, right? So temp.next, because temp is head, so temp.next. So self.head is equal to temp.next, right? And now temp.next must be none, so that, so initially the temp is nothing but the first element dot next, that means we are disconnecting the link, right? So now you can observe L dot delete underscore beginning, right? So hope you understood. We are changing the head position, right? We are changing the head position, and then we are just linking the second head, okay, second element, and we are disconnecting the link from first element to second element, because we are deleting the first element. So just execute this one. You can observe 10 will be deleted. Yeah, see, now 20 will be the starting node. 20 will be the starting node, right? So hope you understood this one. Then so I will just keep hash here. So I will execute. So now 10, 20, 30, 40, 50. Now we'll see the code for deleting the element from the end. Okay, see, for this purpose, delete underscore end. Here also we give the self parameter only, and now just go with the temp is equal to, sorry. So here we need to travel from first element to the last element, and last element should be deleted. So for that purpose we have to go, that means last but one element next value should be none. Okay, the last but one element next value should be none. Now for that purpose I will go with the previous is equal to self dot next, and temporary variable is equal to self dot, sorry, here not next, it's a head, and this is self dot head dot next. That means the first element is assigned to previous. Okay, the first element is assigned to previous, and second element is assigned to temp is assigned to self dot head dot next. So self dot head is this one, dot next means this one. So previous is 10, temp is 20. Now just travel from first element to the last element. For that one purpose, so while temp dot next is not none, so unless it becomes a none, we need to travel both the elements. So temp is equal to temp dot next. Similarly, previous is equal to previous dot next. So at the end of the loop, if the pointer reaches the last element, so automatically the last element next will be none. So automatically temp will be the last element, previous will be the 40. Right? Temp will be the last element, previous will be the 40. Now we need to disconnect the link between 40 and 50. That means previous dot next must be none automatically. So this is a previous, right? This is the previous and this is a 50. Temp. So we need to disconnect the previous dot next. So automatically after coming out from the loop, previous dot next is equal to none. Automatically the link will be disconnected. Now let us execute the program. You will be getting an idea. See, L dot delete underscore end, right? So you can observe the elements are 10, 20, 30, 40, 50. Now I have kept the comment for delete underscore beginning, so nothing will be executed. And here coming to the next statement, that is a delete underscore end, the 50 should be deleted. Just execute the thing, automatically the 50 will be deleted, right? So we are taking two variables. One is for traveling from first element to last element, and the second variable is to travel from first element to last but one, right? Hope you understood this one, right? Next, the next one is deleting the element at the position. So we need to give the position so that the element at that particular position will be deleted. For this purpose, we will go with the self and position, two parameters. Now again, just assign the same thing here. Previous is equal to self dot head. So this is for traveling. So temp is equal to self dot head dot next, right? So if the position is 2, or if the position is 3, here the 30 should be deleted. So just I will go with this one and execute. So there are 5 elements now again. Now if I want to delete the 30, we need to travel from 10 to 30, and we need to disconnect the connection between 20 and 30, and we have to establish the connection between 20 and 40. So for this purpose, again we'll go take the previous as a head and the temp as second element. Now we need to travel from first to a position. So for I in range of 1 to position minus 1, right? So travel the temp is equal to temp dot next. Obviously previous is equal to previous dot next, right? Now simply give previous dot next is equal to, so automatically if you give 3, right, so it will move up to 20, right, and it will be deleted, and now the link will be established from previous dot next is equal to, that means 20 to next is equal to temp dot next. Here temp is 30 now, right? So after executing this for loop, the temp will be moving towards the 30, right, and next previous will be moving towards 20. Now previous dot next is equal to temp dot next. So temp is 30, temp dot next means the link of 40. So here we can go with the temp dot next, right? So hope you understood this one. So in this case we are taking two variables, one is for temporary, another one is for previous, in order to travel to that particular point, and in order to disconnect the link we need to use the second variable, that is a previous, right? So if you execute this one, so just call the function L dot delete underscore position of 3. If you execute this one, sorry, we got some error. Let us check. Position is not defined. Position, yeah. Self dot next. Just a second. I'll give you. Sorry, here we have given the wrong indentation. For that purpose we are getting some error, right? Now you can observe here. See, the third element has been deleted. So if you keep the comment here, if you execute, this is our linked list 10, 20, 30, 40, 50, and if you delete the position 3, that means 1, 2, 3, right? 1, 2, 3. So if you are not giving here 1, we can consider as a index values, we can consider as a index values, right? So here I am considering from 1, so 1, 2 and a 3, that means 30 will be deleted. So if you execute this one, 30 will be deleted. If you execute some 4, 40 will be deleted, 10, 20, 30, 50. And if you execute 2, 20 will be deleted, 10, 30, 40, 50. Right? So hope you understood this one. So deleting from the beginning, deleting from the end, and deleting from the position. So just to draw the diagram on a paper so that these points, that means these steps will be easily understand, right? So it will be very easy to trace this one, as I have mentioned in the whiteboard. So if you draw the elements, and that would be very easy to grasp the concept, particularly in the data structure, right? So hope you understood this one. So I will stop here. So if you are having any doubts regarding this deletion process, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really understood my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.